Okay, so today we have a 16 inches that's low power. Just gonna take out ticket. Uh, 16 inches no power. The model number A2141, 16 inches no power. So first thing you want to do, so it's always advised that before you connect your charger onto a machine, you want to open it up, take out the back cover just to be, to know what's happening inside before you connect the charger, because you're not sure what is the state of the machine. So before we connect the charger, let's take out the back cover to see what's happening. What was that? And you see, and another thing is, when you are taking out your screws, it's always, it is better, not always, but it is better to follow a sequence. You either start from the right to the left or from the left to the right. Then we just need to pop this open. Okay, this has been somewhere before. One of the reasons how we know that is we see there's a missing screw. So definitely it's been somewhere before. So what we want to do, which is basically the first thing, is we want to disconnect the battery cable. Now remove the battery. We also want to remove the battery screw. I'm gonna need a T5. Okay, yeah, I've got a T5. Just take that out. 16 inches. Yesterday I made a video showing the difference between the 16 inches battery screw and 13 and 15 inches. So one is long. 16 inches is typically longer than the 13 inches and 15 inches. So what I want to do is I want to see if there is a short on my board. I'm just going to say, first thing I want to check if there's a short on my PP bus. Continuity mode. And then I can check from either of these fuse here. Either of these fuse, I can check if I have because these fuses are sitting on the PP bus PP bus line, so I'm going to check if there is a short on the. Okay, so we have a short on our PP bus. Okay, let's hope that short is not coming from the NAND chip, because the 16 inches are very common to have a failed NAND chip. Let's hope. Can I have a magnet, please? Magnets, please. There's one on his desk. Okay, yeah. What is that?
That's fine.
What is that?
Just a missed call.
Say again?
Just made a mistake, missed call.
I hope the video is stopped.
No. Okay. Okay, now I'm gonna need a T4. Change the tip to a T4. One day I'm gonna make a video explaining all of the procedure and all of the parts that are I'm also going to make a video explaining the screws and the so when I'm going to make a video on how to disassemble, so on each, what's happening? On each of the on each machine, on each line, I have to make a video on how to take it apart. So right now I'm using a T4. After that I'm going to use a T6 or T8 to take out the two screws that holds the heatsink in place. Now, and I mean, these two screws, they are not the one that goes over the CPU. These are typically the ones that are part of the board assembly. So my T6, 8, the only two screws I need for. Now I want to disconnect the cables. Start from the right hand side to the left. See if you can station it, if it's going to work for you. See if you can station it for you.
From here.
I'm saying see if you can station it, so that you don't have to hold it all through.
I think I can hold it for this one.
Say again?
For this one I can hold it.
Okay. Okay, the board is out. We want to take a visual inspection, test the board. And then take a visual inspection. It's important that you take a visual inspection of your board. That will give you an idea of what's happening. Trying to see if anything is out of the ordinary. Okay, nothing really stands out. So what I want to do now is I want to confirm the short one more time. Same spot, the fuse for PP bus. Okay, 0.30. Okay, that's not a complete short. Now let's check out the the section of the NAND, which is the SSD. See if we have any short in that area. That's not a short, but it's quite low. Okay. The other side. Okay, I think I see a capacitor that doesn't seem to look too good. Just gonna pop it off the board. Now read the capacitor individually and see if it's like our problem. And that is not our problem. Capacitor is looking rather funny though. It's not our problem. Okay. Let's check on this other side of the NAND chips too. Right now, what I'm going to do is I'm going to separate the PP bus voltage from, see? We're going to separate the PP bus voltage from the SSD line. Let's open the schematic. And the board here, this is 16 inches. The board number will be 80-01700. So let's separate PP bus from the SSD voltage. See, can we PP bus? Okay. PP bus there. Okay. Let's remove that current resistor. So that will be I4620. Let's remove that resistor and then see. So what we're trying to do is we're trying to isolate PP bus. Isolate PP bus from okay, so let's just confirm. Let's measure again at the fuse where we started measuring the first time. Let's see. And the short is gone. So the short is gone. So that is because we have isolated the SSD line from the PP bus, and the SSD is joined with the PP bus through R5620. So the short that we're having is not directly on the PP bus line. However, it's on the SSD rail, which has a connection with the PP bus line, which is why the PP bus is also affected. Now, the short that we have, it's basically represented in here. So let's just see. We have a short there. Okay, now we wanna, so by clicking, so this, when I click on this, this is basically where this tells you that you have a PP bus. These are the lines that the PP bus are connected. So I'm just going to flip to the other side and see if you have anything there. Nothing. So what we want to do is we want to remove U9850, U9580 to see if the short will be gone. Let's remove. Let's remove that. See the short is going. Oh, we can also remove these inductors. Yeah, I think it's easier to remove these inductors and then check out what side of the board the shorts are. That will also help. Okay, this is not good. It's looking like our problem. So U9580 is a buck converter. What it does basically in this circuitry is it takes a high voltage and then it converts it into a lower voltage for the NAND chip. Now these are the NAND chips. So we have 1, 2, 3, 4. These are the chips that I use for the storage. In other words, these are the SSD, the onboard SSD of this machine. So what U9580 will do is to take a high voltage, in this case the 12.66 volt, and then turn it into, then switch it, basically convert it into a lower voltage of 2.5 volt. Now, should this become faulty, what will happen is the 12 volt that goes into this, instead of converting it into 2.5 volt, for the SSD, the onboard SSD, it will output the same exact 12.6 volt that comes into it. It will send it straight to the SSDs, and that will obviously kill the NAND chip. So so one of the ways we're trying to establish that now is we took out the NAND, we removed the NAND and see to check out where what side of the other side of the board is short, and it so appears that it's the other side of the NAND side of the board that the short is present. So which would mean that even if we remove U9580, we are not looking at solving our problem. So let's just see if there's going to be anything that will stand out other than the SSD. Let's see if there's anything that could potentially have that could potentially be the issue other than the SSD. I want to look at the caps around. Because capacitors are very common to fail. Let's say if there's any funny looking capacitor. None. Okay, we what we want to do, we wanna inject the voltage, but we will really have to start. We will be starting really small. So we want to inject voltage into the 2.5 volt line, and see what will get warm. I'm very much leaning towards the side of a failed NAND chip. Yeah, but you never know. Let's check it out and see what happens. So to do that, we solder one wire to ground, and then the other wire is going to be soldered to the line that we want to look for a short, or finding a short from. So one to ground, and then the other one you saw that it's to the 2.5 volt output line, which is this. Now we want to slightly slowly increase the voltage and see if anything gets hot. We bear in mind that so just so that we don't get a misdiagnosis, so I'm just going to set the board aside to give it like a little bit of cool, and then we can slightly and slowly increase the voltage and then see what happens. In the interim, we'll quickly check out the other. We have another machine, the MacBook Air. Let's quickly see what that one is. If it's something we can fix. Okay, and this one seemed to be urgent. The problem description says dead. So what we want to do is we want to check out while we're waiting for that board to cool, because we don't want to. So the concept is we want to slightly inject voltage and then see what gets warm on the board. So right now, because we did use a hot air around it, and then also sodium iron, so that section is a little bit warm, so we're just going to put it aside, let it at least let it become cold, then we can go to it. So this is the MacBook Air, and then the problem says it's dead. It's an A1466, so we want to quickly walk around that. Let's quickly work on that one while we're waiting for that to cool off. And the description also says it's urgent. So let's see what is happening to this one. One of the screw is missing at the back. The description says it's dead. So which means it doesn't turn on. Okay. What we want to do is we want to connect our charger to see if we get a fan spin. Connect the charger. No fan spin, but then we do have charger communication LED. So which means now let's check on our basic voltage. Just switch to voltage mode. Let's see what we measure on our PP bus. We will not bother to measure for PP342 because the fact that we have the charger communication LED tells us that PP342 is present, and to some degree the SMC is also running. But now let's see what we have on our PP bus. PP bus is 829, 830, 835, 830, okay. Okay, PP bus, it's slowly increasing. Okay, let's check.
Ashman Zone 3.
Say again?
Ashman Zone 3.
Colin. It's fine. I'll go to it. 847. Okay, let's disconnect the battery, disconnect the charger, and check again. Let's see what we measure. Repeat reverse. There's no fan spin. Let's see what we have on PV bus now. Okay, 8.61. Okay, that's about it. 8.61 inside. That's 8.6. That's fine. Let's see what you have. PP3. Let's see if we have. Okay, that's okay. Fine. Those are our sources present. Are we in SO? The machine is actually on. Okay, the machine is in SO state. It's just that we don't have a fan spin. So what we want to quickly do is we want to take out the board to find out why, even though we have an SO present, the logic board does not, the machine does not start. So we want to quickly take out the board and find out why that is the case. Okay, the battery screws have already been taken out. Clearly has been somewhere before, so we want to quickly take out the screws and see why the machine is in SO state, because we can measure an SO rail, but the machine is not starting. So we want to check out. So one or more rail may have been may be missing, which is why we do not have a fan spin. So let's quickly take out the board, and then we take it from there. Okay, it's a memory stick here. Okay, it's a bit of a, I don't know what that is. Seems like soldering paste or liquid of some kind. Okay, let's put this aside. Do a general check the logic board and see what we can pick up. It's just board. Give it a quick scan. See why we may not be going into SO state. Okay. But the backlight section has been previously worked on. Okay, let's see if we have a short. I'll just quickly open up the schematic for you just so you guys. So the schematic of this is going to be 80.0.00165. So the board view, 80. So the board. Let's see if we have a short of PP3V3_S5. Let's see if we have a short there. Okay. Short, and then we don't have a short. Okay. Okay. So we want to. Brush, a small brush. Yeah. Okay, it's fine. I'll just use this. Let's get another board for sample. Okay, now let's connect our PC jack and see what's happening with the board. Okay, now we have a fan spin. Okay, let's just double check on something. To be sure. Okay. Okay, now let's see if we have an image on the screen. An image on the screen. Start here. We have anything on the screen. The backlight. Let's see if we have image. Okay, that's an Apple logo. So this is gonna go into testing, and then and then the machine can finalize. So this can go into testing. They say this machine is urgent. If you can tell it to come connect to MacBook Pro.
Yeah, but it's not really all that urgent anymore. Because Gabi said it's for the clients Monday. I told
Monday?
You, yeah, I
Okay.
thought you're not coming back, so.
What is the job card number? Okay, now we're going to check out the 16 inches because right now it's going to be actually cool now. So now let's slowly increase the voltage output to see if anything gets warm. Somebody was here. Let's see if anything gets warm. Yeah. So I'll probably It's this NAND chip here. Yeah, this NAND chip. This one, it's the problem. Yeah, it's very common. So what most likely happened here, it's the buck converter got damaged, and then sent 12 volts straight to the NAND, and that obviously killed the NAND chip. So this one, the NAND chip needs to be replaced, and yeah, and then we will be good to go. But then the downside to this is the client is not going to have data, because the data is in the SSD, and that's said to have been 5. Now we'll have to inform the client about the data as well. Unfortunately, the data will not be carried over. Yeah, so putting back the components we took off during the short finding. So we will communicate, inform the client, and then yeah, the client can decide on what to do. So that's going to be the end of the stream. Thank you guys, see you next time.